Hello, friends. How are you? I am Kishan Joshi. Today, we are going to talk about the system design. How we will develop the system. How we will design the system. How any software actually operate at a first level. How how the schema of the software is designed, how the entire structure of the software is designed. This is the particular thing which we are going to talk in this particular video. This is going to be great video, and this video will bring a lot of details regarding how any website is structured. Recently, we can go for the lot of website in the Google workspace, in a Google space, but we are specifically picking the Spotify, and we will make the schema of the Spotify in this particular case. So I will share the screen and show you to yourself how the schema looks first of all, and how entire thing works. I made us for certain schemas, which I also uploaded on my LinkedIn. You can follow me there, and we can connect over there also. So let me share my screen so I can show my schema. So let me share my entire screen. Let's go to the Google. Yeah, that's how the schema look like. I made many of the schemas regarding the Book My Show, predictive maintenance for the industrial equipment, database design of Udemy, e-commerce website, blog post schema, Nika schema design. So I made a lot of the schema. So let's make this even more bigger. Yes, I click on F11 and I made it even more bigger. So let's get into it. Let me put myself in a space where you can observe everything, whatever happening in this particular space. So let's open the predictive maintenance for industrial equipment. This is a great, I think, and I just go for the presentation mode, so you can watch entire thing from here. So yes, how it's going, it looks. Just see the imaginary thing. This is how the maintenance process of industry work. That's how the schema work. If you just want to understand the schema, you can skip it after the schema design process will complete it. But this video will become a very long. Like, I think it may take 1 hour also, and it might be slow when we constructively design the schema as well. So my suggestion to you is just design by yourself with me also. So even if I will go very slow afterwards, so at that particular time you can design with me or follow me together. So maybe this particular video go longer, but no worries. There is a lot of to learn in this particular video. So what we can do in this particular space. So how the whole thing is connected, that the schema shows particular thing, like usage data is connected with part usage, how parts of the different machines is determined. If we see the part, then part has the part ID, and part ID is connected with the maintenance log. Maintenance is connected with the equipment. So it all start with the equipment. Equipment has their own maintenance log, how we actually structurally which particular time we done the maintenance of particular equipment, we done the calibration of particular equipment, how where we done the repairing of the particular equipment. This is all the things captured inside the industry. Because, like, if I talk about the pharmaceutical industry, I worked on the one ERP, enterprise resource planning software company, and I got the chance in going into the many pharmaceutical industry, and the equipment. is connected. Every equipment has their own equipment ID, and everything is specific. Everything should be registered. And if everything is registered, then and then the things can be standardized. Then and then the risk can be reduced. Then the uncertainty can be reduced. And in this particular space, there is a lot of scope for the industrial software as well, and which can reduce the uncertainty and improve the standardization, improve the quality, improve the efficiency of the software. So maintenance log, and a lot of systems are involved when we comes to the manufacturing. Manufacturing has a lot of regulations, specifically in the pharmaceutical field. If I talk about, there is a US FDA regulation, there is a GMP regulations, there is a GLP, and lot like British government regulation, Germany government regulation. So there are a lot of regulations there, and if just one US FDA warning comes to the company, the entire company stock market destroyed in a seconds. So this is the financial impact it generates. The stand to the standardize the system. Every system should has certain things, like if technical person make the SQL, then we have to at least SQL is the language which not understand by the non-technical folks. But to communicate with the non-technical folks, we can use the ER diagram. This is called as an entity relationship diagram. And this is an entity, failure record, maintenance log, whatever the title you can see, it is called as an entity. And that particular entity shows the relationship between each other. So this is the ER diagram. This is great. So let's understand the process. Equipment ID, go for the maintenance log. Equipment ID, usage data is captured. If we go even deeper, then equipment ID has a certain sensors into it. So, and their sensor reading is captured through it. So this all the record is maintained. Then even go we go if we go deeper, then a maintenance log. If we go for the equipment and like some failures will happen, then we have to maintain the failure record at that particular time. At that particular time, this particular place, this particular machine is just called in place. Like if you see the failure record, failure ID is captured. Equipment ID, which particular equipment is failed, we have to register it. Failure timestamp, at which particular time the equipment failed, and which type of failure is this? It is a breakage failure. It is a it is the detection capacity failure. It is just a calibration fault. Which type of failure is it? It is a physical failure. It is just a software failure. At which part it is failed, and we have to describe all the things. So that's how the ER diagram works. You can understand the entire failure thing with this particular by looking at just this failure record. Let's broaden this particular thing. Yeah. So uh, I'm you can actually see these things. Failure record. If you can see the about the equipment, then the equipment ID, name of equipment type, how which type of equipment is this particular thing is. Sensor ID, sensor equipment ID, sensor type. Which type of sensor is this particular thing is? What this showing installation date. You can see the all the things. Like so, in this particular way, the entire thing work. Maintenance task, then the task ID should be assigned. Technician, which technician is involved in this particular task. Everything should be standardized. Everything should be labeled into the industry. So what this particular ER diagram does, diagram does and give this certainty to it. If non-technical folks want to understand this ER diagram, want to understand how the system is working, then the ER diagram is the simplest way to make them understand. So in this particular way, the ER diagram works. If you just observe this particular ER diagram and uh, and try to understand at which thing is related at which condition, then also you can understand the system. So this is also we have to create it. So if you just want to understand about the ER diagram, you can probably skip through this particular video from now. But if you want to make it, like from now, the process will be little slower. So if you are ready for it, if you would want to make the system design for it, then you can follow me together. Like let's go before. Let me don't leave the site. Let me open the DrawSQL again. So I made a lot of things. Like you can see these things. Book My Show, predictive maintenance, database design of Udemy. Udemy is also the structural data set. So Udemy data set design also I made it. So I will upload it entire my projects on the LinkedIn space. So afterwards, after this video, you can also go there and explore how what work I done. But right now we go for the Spotify schema. Yes, we go for the Spotify schema. What Spotify is actually doing at the first place. Spotify schema. Spotify schema design. Schema means a type of data set, like whatever you've seen before, entity relationship diagram. It is basically schema, like how the whole thing is connected together. So this is all the things is about a schema. So let's create some diagrammic thing. So hopefully it will give here. Here this is a draw.sql. Draw.sql. If you go into the Google workspace, you can find this table, and the table creation is very easy. Like, but before we go into the table creation, how we will make the table? We let's understand. Let's first go into the uh, Spotify website. Yes, this is a Spotify website, and you can see a lot of things in it. Let me larger the screen. Yes, Spotify, home, search, your libraries are there, create playlist. So a lot of things are there. Let me hide myself. Yes. Okay. So login, you can see the logging space. Login, we can do the login, we can do the sign up. So what user table contain? Let's see the information. A user table may contain the email address, Google. We can do with the Google sign in process. Like let's see what user table basically contain. User table may contain email address, name, date of birth, gender. Let's see. Let's fill it out. Date of My date of birth is 22 September 2020 2000. Acha, okay. I have to give date here and year here. Sit form it gives in the year, month, date format. So my gender is male, and let's dig deeper, even more deeper. Next button. So how it is collecting the information? Terms and condition. I would prefer they ask for the terms and conditions. Share my registration data with Spotify's content provider for marketing purpose. That's how we can sign up. So what actually Spotify done in this particular event? They actually made their user table inside it. So let's make one user table. And if you've seen the in this particular video, it captured email. Email is connected with the password of Google. So email is connected. Password is connected. They also captured the registration date under the hold. Uh, and with the help of Google, they also got the profile picture of mine. So let's make it. Let's make the design the Apple. Like let's make the user table for the Spotify. User table for the Spotify. User table. Let's make a user table. Uh, Now, what is the ID? Uh, Now we go for the SQL stuff. So the user ID is captured. One user ID, every person has their own user ID in the inside the uh, table. So under the hood, every person has the user ID. When we give the information, user ID is captured into the space of Spotify. So now go for the user ID. Then username. User ID is unique for each other. Username is also taken for by it. And if you see this particular thing, then username is ideally unique to each other. Two people don't get the same username, as we know these things. Then the email they captured, email, they captured, which is also unique to each other. Password they capture. Password should can be unique, but I think it cannot be unique as well. So password, like if you see the uh, data type, what data type is used, then varchar data type is used. Varchar data type is famous for the SQL stuff. So whoever is technical person who want to understand the ER diagram, they can understand by it. Varchar, then password also contain the varchar element into it. Then we can add one other column. How the different tables is connected into under the hood. Registration, birth date they taken. Yes, they taken our information. It's like birth date. Let's make the date. Then what the information they taken? Registration date. Actually, the timestamp. They taken the timestamp of at that which moment you log in into the account of Spotify. Timestamp. Timestamp is given. So let's make this particular thing as a timestamp. Okay. So that's how our user table is created. Then we go for the different things. Like let's go into the Spotify again. You can see the lot of songs into Spotify. So every song has their own song ID. If you can see these things, it is connected with one album. It is date added information is given. Release date information is given. Then we can add to the playlist, save and like the songs, go to song radio, go to artist, go album. You can see the under the hood lot of tables are connected together. Use credit, copy song link, all the stuff. Open in desktop app. Spotify is also supporting a desktop app. So song table can be very big. I think let's make it. Uh, we try to make as simple as and as smooth as possible the process. Song song should contain the song ID. Yeah, every song has their own song ID, and it is containing the title as well. Yes, it is containing the title. Every song has the title. Yeah, and title. The data type for the title is will be the varchar. Yeah, then Spotify, what Spotify actually contain more. It's like it is connected with album ID. So some album ID will be there. So say the album is connected like this is a There is a strange album of animal. The album ID is there. Album ID should be there. So we will make our song more detailed. Album ID. Let's solve the so album ID will be there. Then this album ID also contain the big int. If we go for the album title, then it will contain the uh, let's make album title and we will consider as a foreign key. We will connect album title with each other. Then what things it captured? If you see this particular thing, like uh, so when date added, yes, at which date it is added, at which time. So date added, time added, date added, duration, date added. Where this particular song is added into the under the hood. So what is the date time? We can take the date time and lot of things. Let's take the date time data type. Then release date. Yes, if we go under the hood, release date of the data type is also under the connected with each other. That's how the entire thing works. This is a basic structure of that's how we can delete column if we made the any more. So that's how you can make your own entity and you can try it together. We will make entire Spotify data base schema. We will make it. So let's go deeper into it. Let's go even more deeper. Then which artist table can be there? Yes, Spotify has a lot of artists. I'm literally saying to you, like, who is artist in this particular space? This was all the stuff. Like, you can see the different artists. You can also install app, search, music podcast, artists. If you just write it, Arijit Singh, the entire data set, that number of artists. Like, let's see it. Like, how it's look. It's great. Okay, I just made the mistake. See the artist, songs, playlist, albums, profiles, podcast shows. Everything is stable. Can you understand and correlate each other? That's how the things work. Yes. So let's see the artist table. Lot and lot of artists. See the pictures. See the pictures of the artists like Shreya Ghoshal, Pritam. Arijit Singh is my favorite. Where is this? Arijit Singh. Yeah, he is my favorite. Artist, poet, same. Taylor Swift. Yeah, it's great artist. Fortnite. You can play the song also. It is cool. So there are a lot of songs of Taylor Swift, like so great artist. In the So Long London, and then okay. Hopefully it don't create the copyright. I just made it. Uh, so there are a lot of artists out there. God knows my YouTube video got the copyright because of I just this little songs. Then see the playlists, the 100 most streamed, all artists, top 20 global Tamil artists, art playlist. Spotify is great, yeah. Actually, if you are like so artists you can watch songs, album, genre. Lot of things are there in Spotify. You can see the premium subscription and all this stuff. So what is our goal here? Like our goal is to make the data set out of it. So I what I shown is that everything is connected with the table. Every data is connected with the table. So whatever you can see here is under the hood, it is a table. Every video is connected and everything is organized in the Spotify vault. So let's make the our articles and what let's just focus on some like artist. Which kind of field it involved. We seen this particular artist and all this stuff. If you want to make the data set, what it under the hood, the artist has the artist ID. We have to with the artist ID, it is got registered artist ID. Then let's add the one other column. Then the name of the artist will be there. The song ID will be there. Their creation ID or song ID. Every song their own ID has their own ID. Then biography, bio of the artist. So this is the information about the artists. Then how artist song table. Like let's make or another table. Artist song table. Let me make it more bigger and so we can understand all the things. Let's make the artist. Let me restructure the artist table. How we can restructure? We can go for into this particular name, varchar, and song ID. Song ID. So song ID will be big int. It will be great. Bio will contain a lot of description text. Yeah, it should be text. Then we have the for the unnamed table. Just artist song table. Artist song table. Artist song table. So this is artist song table. Yeah, why we have to write here? artist song table. Yeah, artist song table. And which type of field it may contain. If we see about it, then it contain the artist ID, artist ID. Then it may contain the name of the artist. Yeah, name of the artist also will be there. Of course, it will contain the song ID, which is foreign key, which is connected with another table as well. Then genre and all this stuff, like which genre music it, genre ID. Let's not consider genre. Only we can predict a lot of things with pretty much all the stuff. So I made the fourth table. We will connect all the table. Don't worry. And all the tables relationship is connected with each other. And in this way, we can make the entire project of the schema design. This is a fourth table. Then fifth table, genre. Which type of genre will be there? Like lot of genre. Genres. I don't know the spelling. Genres. Okay. Let's go deeper and search for different genre. Genres and modes. See, genres with music. Different type of genres. And you can see the all the things together. It is great. Genres and music and all the stuff can be seen here. So in this way, you can see the whole thing. Genres and mode. Genres. Then of course, genres contain the genres ID. Genres ID. Of course, it contains the genres ID. Then what it contain next? The name of the name. It contains names basically. Okay, so that's how the genre table is made. Let's put it here. Then the song genre table. Let's don't make it another table. Uh, just make a song ID will be there. Genre ID is the primary key. Then the genre ID. Then song ID is the foreign key here. So you can make the bridge table as well. So deleting the row. So in this way, the entire thing actually work. Then you can also make the playlist table. So what it contains. Playlist ID. It contains lot. Playlist ID. What I mistakenly done is the artist song. If you go for the artist song table, what I done is I don't change the it to varchar, so I have to change it so other people can understand it. Let's go to the playlist table. Genre table also has uh, modification. Yeah. Let's go into the playlist table. It's a playlist ID. And every playlist user ID is also there. Every user has a different playlist, and every user has a multiple playlist as well. So name of the user should be also stored in the data set under the hood. Varchar, the description, description, which is I will make on the text because it requires a lot of reviews, lot of description are there. Visibility status, we will make the enum which has the list, and we will put it in a nullable way. Okay, so that's how we made the playlist table. Playlist song table. Let's don't make the another table for it. One another song ID, podcast ID. Let's make it here. Actually, let's make the another table so we can connect the dots if it's required. Let's change the table. Playlist song table. So what did it? How it is connected with each other? Playlist and ID, and then the song ID will be there. Yeah, it will be there. Then one podcast table column be also there. Yeah, let's go for someone podcast table. If anyone wants to podcast artist will be there. Like lot of stuff. We can make it 10 hour long like video, but we will try to finish it very soon. And because we just want to understand the concept little bit, and podcast ID will be there. So in this way, you can create the table. I just take one table, one on the onto the another. So a lot of tables are there. Yeah, you can see these things. Like this is a mash. Don't worry, this smalling out. Oh, it's look good. Let's go for the podcast ID. It will contain another couple like uh, title and artist. Just understand that we have to do it varchar. Uh, we have to do the name of the artist also as a varchar. Description we have to given. description, which is date, text as well. So this is the thing we have to follow under the hood. Now let's make another table, which is episode table. Yeah, every playlist, every thing, every if you go into the playlist of the YouTube, it has the episodes into it. Like you can see the my favorite. Let's go into the my favorite Ranveer Alabadia channel. Let's go for the Ranveer Alabadia directly. Ranveer Alabadia, my favorite YouTuber. Badia on Spotify. Yeah, yeah, on Spotify also the Ranveer Alabadia is there. So let's see the channel of Ranveer Alabadia. Yeah, this is their channel. So a lot of episodes are there. You can listen every podcast, everything on the Spotify. It's a Nikhil Farmer podcast and all this stuff. So it is great. Let's make the episode table. So there are a lot of episode, but many folks are generating episode table, table, episode table, and let's make the episode ID. Everything is connected under the hood. Episode ID, and if we see into the detailed manner, then then it will also contain the podcast ID. Yeah, podcast ID will be there. Then the title will be there. Title will be there. Description will be there. So title is definitely correcting the text format. And the description also connect through the text format. You can use the varchar as well. No worries, no problem. Then the release date, song release date will be there. We can give the timestamp. Duration from it has, and we will make the time. Okay. So we will make, I think, enough table. Let's make one another table. Like and follow. Yeah, like and follow. User interaction table. User interaction table. Yeah, how user is interacting with which episode, what user is basically doing. So the user ID will be there. There will be the last table, I think, and then we will make the relationship. Then if we go into the podcast ID, one user can watch very many of the podcasts. So podcast ID will be there. One user can listen lot of song. Song ID will be there. Then playlist. One user can collect a lot of playlist. So playlist ID will be there. One user can follow a lot of artists. Artist ID will artist follow. So in this way, so artist ID will be there. So under the hood, lot of table we created. We will make the relationship out of it. There are a lot of relationship which we have to establish in the first place. So let's go into the bigger space of the user interaction. What is the relationship between all the tables? We will make it and we will understand it. Now it looks quite good. We will try to establish everyone's relationship. One user ID. Let's understand this first. User can create a multiple interactions. If we see under the hood, songs. User can create a multiple interactions. So let's connect it. One to many. Go for the one to many. It's not a one-on-one relationship. It's definitely one to many relationship. Why it's not working, I don't know. Okay, well we will solve it afterwards. User interaction. If you see these things, one user can interact with lot of podcast. So it's a one to many relationship. You can see here how one to many relationship is described. This particular thing. Yeah, this particular thing I'm talking about. So so let's go here. So it looks quite good. Then one user can follow a lot of artists as well. Yes, many, one to many. The relationship will be user interaction can be a lot. One user interaction is connected with the artist song, but user interaction, how many user interaction can be happen in one song? So it's a one to many relationship. Let's go deeper into it and let's ask to the chat GPT how the relationship works and what it's suggesting. So I asked the before to chat GPT and it given the certain relationship diagram, user and playlist, one to many relationship. So and user and artist, many to many relationship, both the side of relation. User and podcast, many to many relationship. Maximum thing has connected with the many to many relationship. Unlike so in this way we can establish the relationship one to many. Then we establish other relationship as well. User the song ID. one to many relationship. Song ID, one song can be performed by one artist or more than one artist. So this is also the many to one to many relationship. If you see, and a artist can perform a multiple song as well. So this is also, it's a both side of relationship. If you, so one to many. So you can see the both side of the things together in under the hood. In a maximum condition, the one to many, many to many relationship will be there. Podcast can connected with the lot of artists as well. User interaction, podcast ID. One user can watch the many podcast, and many podcast is watched by the one human being also, and one podcast is watched by many person. So if you see that this is also the many to many relations can be possible into the maximum time. What actually happened at the first place is in a this particular database, the many to many relationship will be there. Oh, we done lot. So let's have some cup of coffee. Yeah, we need a copy actually. Like coffee is quite great. Let's have the cup of coffee. Whenever you are a lot of things, it will be great. Ah, it is satisfying you at a massive scale. Yeah, it's cool. So in this way, the entire thing work. Song is connected with a lot of genres, and genres is connected with the lot of songs. But let's take the very simplistic genre. Is one genre is basically having the lot of songs, so we are making it final. Then playlist of the song. Let's go into the playlist of the song. Playlist can contain a lot of song. So one to many relationship. We have to pick this blue color. This is quite tough, certain sense. Let's make it big. We can do it. Has a lot of authority, a lot of things. Playlist song. Yeah, it seems like I don't want to go. Yeah, it's going. Again, it's a one to many relationship. We don't done a like what we did a mixing here, like and like that's how the year diagram is. We have to go under the hood and understand, and in this particular way, we can if the mixing has happened, then what we can do is we can uh, actually reduce the mixing up of the content in this particular way. Playlist contain a lot of inside the place. I think it's a one-to-one relationship because playlist is also the song. So let's take it as a one-to-one relationship. Yeah, this is great. In the episode of the podcast, one podcast has a lot of episode and podcast ID. And if you see the playlist, then playlist to episode is quite If you see it, then it's basically one to many relationship under the hood. Yeah, it's quite, looking quite good right now. We're taking the shape. We are making the shapes. Let's ask the chat GPT again how we will solve this particular issue together. Chat GPT. Then user to podcast, songs to artists, songs to genre, song to playlist, users to songs to plays. Lot of things are there. So we almost covered up entire schema. If we covered less, then we will go for it. Genre ID is connected with, I think, this is a user interaction stable playlist. Artist ID. Yeah. One user can interact with lot of artists as well. So let's connect artist ID. Actually, it's a many to many relationship, but I am showing only one to many relationship because it is quite simple for you to digest at a, why it is not. It is quite rigid in terms of. I need a line, yeah. Like, what is this? Anyways, our table looks good. Yeah, it's under the hood. Like, oh, we connected it, but it's a one to many relationship. Yeah, but things looks good. You have to show the lines as well. This is a table which we have to show. So I think we prepared our own database design, genre, song ID, all the stuff. So let's go deeper. Let's escape the presentation. I think let's we can take the screenshot up here. Let's look. That is the particular thing which we are looking for. Let's go into the presentation mode so we can see entire thing. Yeah. So uh, this is really great. What we are made is really great. So that's how the things actually look under hood. That's what I want to show to you. Let's escape to it. We can save together. We can go into our profile. You can see our profile as well. This is my profile and all the stuff. I don't know. Diagram. We can go into the diagram. And yeah, Spotify schema is also there. It don't look nice, I think. We have to change it something because certain fields are going into certain direction, which is not so great. It also should look great from the outside perspective as well. So let's reduce the, Now I think it looks quite good. Let's see into my profile and see how diagrams looks into the particular space. So yeah, like what is certain things are mistaken. It don't looks great from the outside, but we've seen this thing. It looks great from the inside. So there's a seven different thing is connected. Yeah, that's all about this video. Let me stop sharing the screen. How was this particular video is all about? It's a Spotify schema design. We explore a lot in this journey. We explore about how the predictive maintenance and all the stuff is working in under the hood. We explore that how the different system design work together. We explore that how we will structure our thoughts and how we will put the things in a certain pace that works for us, that works better for us. So this is all, and that's how we can do the best schema design together. Thank you so much for listening. Hope this particular video give the value to you. Thank you so much. Thank you so much. Like, share, subscribe.